All right, good evening, everyone. Once again, I was meant to understand that our presenter or our guest for today is currently on board, and this time that we are about to use for the meeting supposed to be his rest hour. So we'll not waste time any further. I will introduce him and allow him to have the floor. So I will call on Engineer Emmanuel Edere to do the introduction, while I will share my screen to display the profile of our presenter for today's webinar.
Good evening, ladies and gentlemen. I trust we all had a wonderful Sunday. Thank you so much, Engineer, for giving me this opportunity to anchor this segment. I want to say it's a great privilege in a meeting like this. I really appreciate it. All right. It's my honor and my privilege to introduce our speaker for today, Engineer Mkpa. Engineer Ene is a second marine engineer with over 10 years of combined offshore and maritime industry experience, coupled with 5 years of academic research service as a maritime engineering lecturer and head of department for the postgraduate diploma program at Maritime Academy of Nigeria. He has delivered advanced training in offshore and subsea engineering, bringing together real-world engine room expertise with strong academic leadership, research supervision, and curriculum development. His work focuses on safety, regulatory compliance, operational excellence, and preparing engineers to meet the demands for modern maritime operation. Today, we are privileged to learn from his wealth and practical experience and academic insights. Ladies and gentlemen, please join me in warmly welcome Engineer Mkpa. Thank you, sir. You're welcome, sir.
Engineer Ante, please, you have the floor. I will also share your slide. I know you might also have from your end. Please, you have the floor, and the timing is also in your hands. Thank you.
All right, thank you everyone, and welcome to today's webinar. My name is Mkpa Ante, Engineer Mkpa Ante. It's great having this floor today. It's great communicating with you guys, and initially there are a lot of things involved, but today we just focus on marine the engine room simulation. As previously introduced, I have experience in offshore and subsea operation, and also lectured maritime engineering in Maritime Academy. So it's just a wide field, but today we are going to focus on basically marine engine room simulation. So first of all, let's look at what's the engine room. The engine room is basically the heartbeat of the vessel. It controls the propulsion, power generation, heating, cooling, everything that keeps the ship working comes from the engine room. Some people think the bridge, but the bridge is basically it's sort of like a communication, the nervous system of the vessel. The engine room is the heartbeat. It keeps it pumping, it keeps it operational. So this section we'll be talking about the layout of the ship, the system safety, mechanism, emergency response, and basically the essentials that engineers needs to know about this vessel engine room. Let's start with the engine room layout. In most engine room, you'll start with the main engine. The engine room layout would consist of, if you're looking at shaft system, you have the main engine, the shaft operations, which drives the vessel. The auxiliary machinery areas, which consists of your generators, your compressors, pumps, and all that, and your engine room. Your engine room is basically like the brain of the operation of the engine room, because where the system is running, the ECR, which is your engine control system, is for you to monitor how every other parameters operate. You sit down there, you see how the engines, the auxiliaries are being run. While your workshop and your maintenance or emergency system is basically for you to see how maintenance readiness and emergency preparedness, what you do in case of moving on. So you look at the our main engine components for the main engine. First, you look at for all engines, both four strokes and two strokes, you have your cylinder blocks and your crankshaft. Those are the core factors in your engine, because those are what converts the combustion energy, the explosion in your cranking, your cylinder head, everything to change your combustion power energy to rotating energy, your rotational power, for it to run the propellers and every other thing. So you look at that and you look at your turbochargers. Part of the turbochargers is to supply fresh, it uses your exhaust gas to supply air for you to have efficient burning, efficient combustion in your system. Your fuel injection to consists of your settling tanks. That's right from your cargo tanks for fuel system. Your cargo tanks comes to your settling, to your day tanks. Then you talk of your fuel injection, which delivers high pressure fuel for combustion to take place. Your lubrication system is basically to keep away wear and tear and also deals with cooling. And then you're talking about the real cooling system. Your real cooling system is basically just to keep the engine temperature at normal so you don't have thermal cracks. You don't have any overheating, everything runs smoothly. For your auxiliary machinery system, you talk about your pumps, your bilge pump, your cooling water system, essentially for ship stability and safety. You also look at your air compressors. Everything about the system comes into play because they all have their part to play in your engine components. Yeah, please move to the next slide. Okay, yeah, let me see your next slide. As I'm looking at this, all right, we are looking at your cylinder blocks. You have your piston liners, your connecting rod, your crankshaft rotation, and conversion of combustion to motion. If you consider your cylinder blocks and crankshaft, those are the real system. We are not talking about the whole main engine system. We are just talking about what we need. Your piston and liners, they handle your combustion, where you have the injection of fuel, compress the fuel, you compress the air. At this injection, you have an explosion. That explosion tends to generate a force that pushes your pistons down, creating a rotationary force that you use to drive your propulsion. And that same force is also used with the alternator to generate power, which helps in generating electricity that is sent to your switchboard, where you use it to power the whole vessel. So that's really the idea, from combustion to rotary energy to your mechanical energy. That's what you have with your engine components. Your fuel system, you move from your fuel pumps, which provide a high pressure energy, your high pressure pump, to the injection, to the injector nozzles, which creates that explosion. It delivers high pressure fuel to your system for you to have your combustion. It's as precise as ever. Turbocharger is basically conversion of your, when you burn fuel, you tend to eliminate exhaust gas. But instead of just letting the exhaust gas go to waste, that exhaust gas goes through your turbocharger, which has both an exhaust part and a compression aspect of it. So your turbocharger is like a fan. While the exhaust is going out, it tends to rotate the compression side. The compression side then sucks in air, giving you enough sufficient air to help you have efficient combustion. It improves the efficiency and your combustion rate, so you have enough air to burn in your combustion chamber. Your lubrication system, you are looking at the lube oil pumps, your filters, your coolers, your bearing protection, reducing friction and wear. Your lubrication system is basically keeping the system from wear and tear. One, it also helps in cooling the system because your lube is not just for lubrication. It also takes away heat. It also acts like a cleaning agent. It cleans away particles to keep the system operating smoothly. So all this comes in play in your main engine component. They all have, each of them have their work just to keep your system running efficiently. When we look at the cooling system, in most vessels, your cooling system could either be your seawater cooling, your central cooling system, where you have a cooler, have seawater run through that, and fresh water. The fresh water tends to like, the fresh water is the one that circulates in, so it tends to keep your system clean, while your seawater cools the fresh water, takes out that the heat energy from your fresh water. For piston cooling, if it's fitted like it's stated, piston cooling in most cases, in most vessels use lube oil. It has a designated, a segregated lube oil system that is used for piston cooling. But in most cases, if you are using fresh water, then it must be high temperature. High temperature fresh water could be used for that because you don't want to create a crack, a thermal crack, whereby you use cold water at the bottom of your piston. Piston cooling is basically underneath the piston. When you have combustion, there's high temperature in the system. On top of the piston, the temperature is very high. So if you have that high temperature, then you run cold water through the bottom of that piston. Automatically, it will crack. The piston will crack. So in that aspect, you don't need a cold water. You need something high temperature water to take a little bit of the heat. You're talking about 300 degrees Celsius of heat. So you take away a little bit of heat temperature from the piston, and that just saves it from having overheating in your system. So that's what you get for piston cooling. Jacket water cooling is basically for your cylinder liners. You cool your whole system at the top, while the rest of your normal heat exchanger. Some heat exchangers, you get your seawater cooling for high and low temperature. The low temperature aspect of it is to cool your lubricant. It cools your fuel, it cools every other aspect, but your high temperature is looking at your jacket water for your cylinder liners or your piston cooling. If you're using water or lube oil for piston cooling, so that's what the high temperature side of your heat exchanger. Your cooling system is basically to keep your system running at optimal level, but at a normal temperature so that it does not have any issues of crack, thermal crack affecting it. So you have it running continuously for a long period of time where you don't have any issues with it. So that's basically for your main engine components. Engineer, can you move to the next slide? Let's look at the auxiliary system, please. Engineer, mm. Hello, engineer, can you hear me? Okay, let's talk about the auxiliary system. All right. The auxiliary machinery is basically every other system that tends to like contribute to the main, keeping the main system, the main engine working. Everything contributes to that. Your main engine is just on its own, but you need other supports to keep the system working and stabilize the whole vessel. You're looking at your build, your pumps, your air compressor, your freshwater generator to keep it everything in comfort on board the vessel. When we are looking at pumps, you have your bilge pump, your ballast pump, your cooling pumps. These are basically to help the system in stability, in cooling, in sanitary, in emergency. That's what your pump comes in. There is survival for emergency aspect of it. If you're fighting fire, if you're fighting bilge, if you're having a drain, you need your pumps to be efficient and ready at every given time. Your pumps also deals with your fuel and load oil. Like we talked about your fuel system in the piston in the engine. You have your fuel pump that deals with circulating of fuel or transferring fuel from your cargo to your settling tanks where you have filtration. Then from your settling tank to your day tank. From your data, you then have it purified and send it to your engines for operation. We have your fire pump. This is basically for emergency purpose. You have your emergency fire pump and your main fire pump. Those are mainly put on board so that you could, for emergency reasons, where we know we are operating in an isolated environment where you're just there alone, but you need to be alert on all the risks involved in shipping operation, in offshore operation, not only shipping. The maritime operation is basically there for everyone, whereby in case of emergency, you cannot leave anybody behind. It's like the military. Once you're at sea and an emergency comes up, it's expected that everybody would have to get involved. From your location, the closest person has to respond. Whether it's pirate ships, that's one of their reasons. Like, if somebody might come to rob you, they are pirates, but if it comes to an emergency situation, you're expected to save those lives. Life is paramount, and how do you do that? So you need to be on top of your game. Your machineries has to be completely efficient and ready to go. We look at the air compressors. Your air compressors is basically in most engines, in most systems, these are used to run the service system, your operating valves, and also for your main engine. Some main engine uses the high air pressure to start. It gives you your initial starting air for you to start the whole process. And it also saves like control for valves, for quick closing valves. And your air receivers, you need to drain that at every given time. And one of the things we always used to that comes up in most exams is when you resume duty, what are your duties? What do you do? One of them they always look at this aspect of you having to drain your air bottles because of condensate. Because if you don't do that, you end up having water going through the system, and we all know that water is incompressible. You can't compress that. So when water passes through your system, it tends to add like a block. It cause a block for all systems. You won't have efficient operation. You can't start your system because you have water which is uncompressible. You can't compress it, so it doesn't work for you. So you need to drain it when it condenses in the air bottle before it goes into your system. So you need to look into that in every system. Freshwater generator, in most of us might not come across this, but some of us will definitely do. You're operating on vessels that have a lot of people on board. In the recent system, most of us right now I'm on a vessel for accommodation. We tend to generate our own water, so you must use your seawater. You tend to use reverse osmosis, which is the most popular aspect of it. You use reverse osmosis, separate the salt from the water. So you then add a little bit of desalination and you process that water just to get it to be a little bit portable for you to consume or for you to use for daily operations. Although most people don't drink it, but if you process it well, if the system is good enough, that water is fresh enough for you to drink. It's always okay. So it basically produces potable water for daily operation because you can't be buying water at every point. You don't have sufficient water on board. Having to buy that. The water is costly. In marine system, water is very costly in the maritime sector. It's very costly. So it's a plus when you could produce yours. So you're looking at your freshwater generator. Some vessels tend to produce water from compressed system where you boil the water at high pressure system like 7 bar. That makes the water boil and evaporate. Then you tend to condense that evaporated water and use it as your potable water. So you use your there. That's where you have the heat and vacuum distillation, where you tend to boil the water, it turns to steam. You then condense that steam and then you use it for your domestic water supply. Your steering gear. Let's look at the steering gear. Your steering gear is basically a mechanical response system. There's most vessels now, when you talk of diesel electric, the idea of diesel electric is basically you generate power, but instead of using fluid, you're using the electric generation you send the electricity to a transformer, which then controls the steering system, your rudder or your propellers. So what happens is in the steering gear system, initially it was hydraulic rams where you have hydraulic fluid doing all that. You pour fluid from one side, the hydraulic goes from one side to turn the steering one way, and to the other side it turns the steering the other way. But it's always a closed system where you do all that. It's always a closed system. The steering system is mostly closed because you tend to keep that within, you have it to react at a given time. I think the standard is about, you need the vessel steering system to move from 35 degrees to 30 degrees in about 28 seconds. So you need that for you to pass your classification test. So that's just your survey test for each vessel. So you need to find your steering gear also. You have this emergency steering system, which is something most of us really need to be familiar with, because if you then have an accident or you are in an emergency situation, you need to know how to steer your vessel, where to run to help the vessel keep afloat, to keep it in motion. We have had instances whereby the main steering system tends to back up, it fails. And the only option we had was running to our emergency steering point just to get the vessel away from the rig. I've had that instance twice. So when I resume on board, in most cases, I tend to take all crew members down to the steering gear and show them how that is operated. Please, we should make it a point of duty of going down to our steering compartment to see how the steering gear, the emergency steering system operates. Please, that is something that all marine engineers should be interested in. Everybody on board should be interested in that. Uh, so let's go to the next slide. Let's go to the next one, please. Power generation, yes. Think you spend some time here. All right. For vessels, like I said, most ships use your main engines for propulsion. In some instances, the main engine also is connected to your shaft generator. This is basically a high power alternators that tends to give you a high power production than what you normally have from your generators. So when you're looking at diesel generators as your prime mover, you're looking at generators that is connected with your shaft to your propeller. So with that, you have to have, if you're using a two-stroke, is direct connection to your propeller. If you're using a medium speed or high speed generator, so you're looking at having a reduction gearbox just to have that for to work that with you. So your diesel generators is mainly used for propulsion. If you're looking at propulsion, it's your power system. It transmits the power that drives the vessel, and in most cases, you're connecting them to your alternators. The alternator converts that mechanical rotating energy. When you have your combustion, it makes your piston moves in a reciprocating motion from your shaft. Your shaft is connected to a rotor in your alternator, which generates electricity, and that electricity is then sent to your switchboard, which gives you power on board the vessel. That's where we produce all the power the vessel needs. So we have your main engine if you're using your shaft generator, or we have your generators, which is basically the same thing. Your generator is basically a machine, your diesel generator connected to an alternator just to get you to have power generation. So when you send that power from the alternator to the switchboard, from that switchboard, it's sort of like a branch. It branches into other circuit breakers where you then control the system. Your main switchboard is the major mother of it all because it takes the highest load, and then you use your transformer to drop down that power. You step it down to be able to operate other smaller equipment, machineries on board. It's like when your main switchboard, you might have your thrusters connected to that. Then you could step that down for your pumps. From your pumps, you step it down to smaller machineries, then to your lighting system. So your switchboard does that. Your power distribution is something we all need to understand because when you have a blackout, that's where you run to. If you understand your power distribution, you'll be able to know how you could get your power back on when you have blackout. It's one of the things. What if your main power fails? That's when we have your emergency generator. One of the rules of the emergency generator is supposed to kick in 45 seconds if your main power source fails. So you're talking about if something happens and you tend to have a blackout, your main engine shuts down or your generator switches off, it's expected that your emergency generator should come on in 45 seconds. And before it even comes on, you're expected to have your emergency lighting on. The emergency lighting should be off for, I think I've forgotten how long, but your emergency generator should have enough power to last you for about 18 hours of your operation. So as to get you back to fixing what went wrong. Why it's called emergency generator is not supposed to be operated as your main generator. It's just to keep you running until you figure out what went wrong for your main power source to go out. So when you have blackout, don't tend to relax and feel like, your emergency generator should be the one running. No, it's just to help you out, and it's only for essential machineries, essential equipment. It cannot power the whole vessel. It's just to keep you afloat till you figure out what went wrong and you fix it to get the main system back online. It has its own independent fuel system. Let's take note of that because why that is done is that if there was a reason that your main system tends to black out, your generators black out because something you might have dirty fuel, you might have anything that affects the main system. It's assumed that you don't want that to also affect the emergency generator. So the emergency generator is sort of segregated from every other aspect of the ship. So you keep that far away from other machineries. The fuel system is different. The filtration system is different. It's also connected to certain preferential breakers, whereby those are just to keep you operating for a short period of time. It's segregated from and independent from every other power source so that it keeps you up for 18 hours for you to figure out why you have a blackout, why your main power system went on. Like I said, in 45 seconds, it should automatically start and kick in just to give you essential load, essential power for you to figure out what went wrong and how do you go about fixing that deficiency, what caused your blackout. All right, let's see the next one. Okay, boiler system. Uh, when we are looking at boiler, most of us will not come to this point, but when we look at boiler, your boiler system is basically a secondary base. In some aspect, boiler is your steam boiler or your gas boiler. Your gas system is gas turbine or steam turbine is used for operation. But when you're looking at boiler, you're basically talking about steam. It's basically a means of generating steam in a compressed system, in a compressed, like a pressurized vacuum, a pressurized system to generate steam. We considered like a pressure cooker, the pressure pot we use at home. When you close the pressure pot, you have the small nozzle, and then when you put light fire to it, you realize that compared to every other pot, open pot we use in our home, the pressure pot tends to boil things faster. The only reason that happens is because the pressure inside is less than the atmospheric pressure. So the heat, the boiling water gets to 100 degrees at a very fast rate. And you have the superheat, so it becomes very hot. So everything you put in there, because of the internal low pressure inside of it, tends to boil faster. So that same system is being applied to a boiler where we generate steam. When we are looking at the auxiliary boiler is basically a backup boiler. In that aspect, you're seeing it as if you're trying to like create a different ways of using your heat energy to produce steam. You're looking at another way of generating steam for use on board. You could have your oil-fired or exhaust gas auxiliary boiler. The idea of the oil-fired is you use your oil, dirty oil or so, you use that to generate you all light the boiler, generate steam, or in most cases, you use your exhaust gas from your generator instead of just letting it go to waste. You pass it through the boiler system for you to boil water and then generate steam from that. There's something we tend to look into on boiler system because you're looking at when you're using oil-fired boiler, you need to be very careful. But in oil-fired boiler, you have a system whereby when the temperature gets to a certain point, you have enough steam generated, you could control it. But in the exhaust gas boiler, is the generator's exhaust that tells you that produces the quantity of steam you want. So it's not really you can't generate that. So it's basically as the generator, how much exhaust temperature is being released from the exhaust gas that helps you produce the steam in your auxiliary water boiler. Some vessels use that to generate steam or hot water and all that. So it's used for different reasons. Some of them you push that steam back into the system to sort of like warm up the old line, warm up your heavy fuel for operation. So it's a way of heating up your domestic use for fuel heating. If you're working in a cold region, you use it to heat up the old vessel, and it's a way of raising the humidity on board your vessel. Some aspects you could still use that to generate water. Like I said, the steam, you condense the steam to generate your fresh water maker. So it's still part of it. It works both ways. So in your boiler, you have a clean return and dirty return. The idea of the return system is basically when the boiler passes through the facility, you're looking at steam that goes through your fuel, your heavy duty fuel tank just to warm it up. It goes through warming up your low boil and all that. Those kind of steam, when they pass through the system, they return, you might think of them as a dirty steam, as dirt returning. So you don't put that back into the system directly. Because if you have, for any reason, you have a leakage, you then have oil being introduced into your feed tank. So while if you're considering for water maker, your fresh water maker, those are clean returns. Those ones can come back straight to your feed system. So you tend to figure out a way of observation. There's an observation tank you use to monitor the liquid coming back. If you have oil on board on top of the observation tank, you tend to drain it at different levels just to get it done. And another thing about boiling system is it has safety. Safety is paramount because you're looking at a very high pressure steam on board your vessel is an explosion ready to happen. In any means, it's an explosion ready to happen. That's why the survey for boiler is very critical. When you have a boiler system on board, you survey that twice every 2 years. They carry out a survey for boiler, but when that boiler is 8 years old, you tend to survey it yearly. So they are very strict on boiler operation systems on board. We have a lot of pressure gauges. We have uh, pressure gauge. We have pressure. You tend to see your side glass. You monitor the steam temperature. You monitor the pressure in the system. But the boiler is a critical system. Like I said, it's an explosion. It's a bomb ready to happen. So it's a very critical system on board your vessel. So let's see. Let's go to the next one. Yeah. Fuel oil treatment. The fuel oil treatment. Sorry, I'll be going off the video because this thing is quite running slow. So I'll go off the video, but I'll still be communicating with you guys. I'll still be online. When you talk about the fuel oil treatment system, uh, when we have the fuel system starts from your cargo tank, which basically is your storage tank. You tend to have fuel supply, different samples, different fuel supply to us on board. But when you get this supply, one thing that we tend to be very careful about is not mixing different fuel supply together. Because what you're trying to keep away from is contamination. So you don't take contaminants from one fuel and you put to the next one that is being supplied. And we do that also because in case of that happening, you know, oh, this was who supplied this fuel to me. So this is where I got this from. So you'll be able to know where the contaminants come from and not spread throughout your fuel system. So the fuel system starts from the cargo tank or the storage tank, which is then being transferred to your fuel pump, your fuel transfer pump, to your settling tank. From the name settling tank, it's basically that when you send it to your settling tank, it's where the debris, the dirt settles. The settling tank have drain lines where you could drain them. In most aspects, the settling tanks also have steam or heaters where you heat those fuels up so that you could separate certain, you have water in them, you separate some of those particles because when it's warm, it becomes denser and you have the separation taking place in your settling tank. Heavy particles goes down, which you could drain out in your settling tank. From your settling tank, your fuel would go through your centrifuge. Your centrifuge could be your clarifier or your purifier, where you take out solid particles, you tend to take out water particles to get a cleaner fuel. From that purifier, it's now transferred to your service tank or your day tank. That is where your generators take supply from. So what happens is, in most cases, you realize some people, those tanks are quite small because they don't want you to keep the fuel there for a long period of time. They need it to be small so that you know that on daily basis, or it's not very few days, in a short period of time, you always purify the fuel going in there, so it keeps it clean. So you always have clean fuel you're running your generators or your engines from. So your fuel treatment system, in some aspect, you tend to add additives to fuel just to eliminate, maybe you make it eliminate water content, sulfur content, so as to reduce the sulfur content of the fuel. You add additive just to make it more efficient and make it more okay for you to use. When we are talking of fuel system, we also consider the heavy fuel. Heavy fuel oil, those ones are used for mainly two-stroke engines where you have to burn them sort of thick oil, but you have to heat them up. You mix it up with diesel because they are cheap. You could switch it with diesel. The heavy fuel is cheaper than the diesel oil. So most people run with that for a certain period of time, but when you're getting into the pot, they switch to diesel. So if you're running a dual fuel system, you need to consider that for your fuel treatment plant. So that's basically for fuel treatment, please. Cooling water system. Like I said before, this is priority because you have machineries running. There are machineries on board that runs the all year round. When you have machineries running all year round, you need a way of keeping them cool. You need a way of withdrawing, taking out the heat from them just to prolong their life and operation. And when we are looking at cooling system, the best source of extracting it, the best heat extraction source is seawater because you have that in high quantity. It's everywhere as long as you're in the maritime sector. So the seawater is always a major source of heat extraction. So the seawater on board your vessel, the way you get your seawater is from your sea chest. Your sea chest is an opening on board your vessel that opens out to the sea. It allows controlled seawater into onto the ship. It passes through a strainer because it might be dirty, so nothing comes through that, goes through your sea pump, and then you use that if you're using a central cooling system. Your central cooling system is basically deals with the seawater cools fresh water, then you have fresh water running through your whole vessel's cooling system. That really helps in that seawater is corrosive, so you know that you could trace the minimum access that the seawater is on board your vessel. You have minimum encounter with seawater on board your vessel. Comes in, goes to your central cooling system or your heat exchanger, and it goes out overboard. So you know it's basically less than 10% of your cooling system as seawater. Every other system is freshwater, so it keeps the vessel piping secure. But in most vessels, like I said, seawater is the best source of heat extraction. In most instances, the vessel tends to allow the seawater goes through all the cooling system. In that aspect, you're looking at efficient cooling, except you're in a region where the temperature, like tropical Africa down here we are, our temperature is quite high. But if you go to the southern hemisphere, the South African and all that, the temperature is quite cold. If you sail to Namibia, South Africa, and out from that aspect, you realize that the water is so cold. My last trip down there, it was so cold that my generator was sweating like as if it was a cold water. We were bracing the generator just to have heat. So all that you need to consider then for your cooling system. Let's look at the seawater cooling. The seawater is, like I said, comes from your sea chest. You pass it through your seawater pump, removes the heat around all machineries if you're using it directly. If you're using it directly, it's access to everywhere, and then it's a best source of heat extraction on board your system. But if you're using freshwater cooling, then the seawater is basically used to cool the fresh water. Because the fresh water will be running around the vessel, you need a means of extracting that heat from the fresh water. The freshwater system is a closed circuit system whereby the water is just in there. It does not reduce. You don't send it overboard. It just circulates within the vessel and have the seawater cool it. On the freshwater system, you have the jacket water system, which is basically an high temperature cooling system, and you have the low temperature cooling system. The jacket water system, like I said, is basically used to cool your cylinder liners. It cools your cylinder liners, your piston, if you're using that. So you use it for piston cooling, and your while the low temperature side is used for your lube oil cooling, your fuel oil cooling, while the system is operating. So it keeps your generator, your internal system at a optimum temperature, operating temperature, because you realize that if you start an engine, even your cars, you're being advised when you start the car, you let it warm up, you let it steam on. Why? Why do we do that? The major idea about starting your car, let it to steam to warm. One is basically when you start your car from rest, the lube oil is down below. The pump in your car starts to pick up that lube oil and circulate it around the engine. When that is being done, the lube oil is quite cold. The system is cold. Could bring about shock, thermal shock to your system. But as it heats up, as the system heats up, the lube oil would go more into different areas to lubricate the system, lubricates the joints, and also takes away all debris. Debris is acts like a cleaning agent and cleans it all up before you start moving. Because when you fire that car, you're now making it work. And while the car is working, you need a means of lubricating it, keeping it fresh. You need a means of lubricating it and keeping it fresh. Engineer, are you there, please? Because I think I've lost my projection. Engineer, okay, let's continue because I think I've lost my projection on that. Okay, let me see. Let me get my own document on that because I think Engineer Bond does that actually. All right, we're looking at the cooling system. We're looking at cooling system, please. So let's look at the heat exchanger. Our heat exchanger, we have the plate type or the shell and tube type. Plate type is basically, it's more efficient because you tend to have uh, heat exchange. About 87% of heat exchange carries out in the plate type compared to the shell and tube type. The shell and tube type is basically having one fluid pass through the tube, the other fluid pass through the shell. But the plate type tends to give you a wider surface area of heat exchange, so it's more efficient than the shell and tube type. So the heat exchanger from the name is basically having heat move, being drawn from one medium to the other. One medium goes in, it drags out the heat from the other one. So that one that drags out the heat, the temperature becomes higher. The other one, the temperature reduces. So that's how I would call it an heat exchanger. So a heat exchanger is a means of separating one fluid from having contact with the other, while also keeping the temperatures of both fluids at a minimum level, at a optimum level. Uh, I tend to make people understand that your evaporator system in your ref system, which Engineer Bond taught last time, the evaporator system and your condensers are heat exchangers. It's just a means of keeping your high pressure freon gas being condensed to liquid. So in your condenser and in the evaporator system is basically the liquid gas at low temperature turning liquid, turning into gas in your evaporator. So it draws out heat from the environment and becomes gas before going into your compressor. So the heat exchanger is basically keeps two fluids from having contact with each other, but also they interact only through taking it from one, each of them, they tend to control each other. So in most cases, you have for your generators, you have the thermostatic valves, which if you start your generator is running and the temperature is low, your thermostatic valve will not open. But when you have high temperature, it opens and allow fresh water comes in to reduce the temperature and it keeps your system operating at optimum level. It keeps it operating at optimum level. The next one would be your air starting system. I said it before, in most instances, vessels tend to use air to start. The idea is basically when your engine is at rest, when your engine is at rest, you need something to give it that initial motion, that momentum to kickstart. And what is the best way that you use an electric motor? So, but in most cases, because we are looking at the means of whereby you don't have less energy, it's just neutral without having much access to electricity and all that. So you tend to use air starting. You have very high compressed air, about 30 bar. It goes into your cylinder and pushes the piston down. That first initial push gets the piston moving, slams at the bottom dead center, and while it's coming up, it's compressing the air in the system, and then your injector releases fuel into the system, explosion takes place, and the system kickstarts on its own. So your initial air starting comes from your starting air system, which is high compressed air. Your air starting system starts from your air compressor, which compresses air from the atmosphere to high pressure. It transfers that air to the air receiver bottles, and those air receiver bottles is the one I was saying that you tend to like, you have to keep draining it, the condensate from it to keep it active. You keep draining the condensate because you don't want water which you took from the atmosphere that condensed to pass into your system. You want that out of the system. So let's look at your control room, your engine control room. I started telling you that the engine control room is like the brain of the engine room, where the engine itself is. Where the engine itself is your heartbeat, is like the heartbeat of the system. The brain is like the control room is the brain where you monitor every other thing. The control room monitors the parameters, it monitors both the main system and the auxiliary system. It's a means of communicating with every other machineries in the engine room. You tend to look at how they are operating, what they are doing. So you see in relation with each other, the control room keeps you at a comfortable space where you see it clearly. It's like a general at war. You turn in the control room, you see how each machineries operate. From the control room, you have access to communicate with the bridge. From the control room, you have access to understand how the emergency system would operate. If there is a fault while you're in the control room, it should give you an access to realize, oh, something is wrong. How do I deal with this fault? And what's the fastest move you have to make? So the control room is believed to be, in most cases, man in engineering sector. Most cases, most vessels now use man system because if you're using an unmanned system, good for you. Because in the unmanned system, you could send the control to your cabin or you go rest. But once you have an alarm, you come down every 30 to 1 hour to check what's going on. You go your rounds. When you're doing your rounds, you make sure you call the breach. You inform the breach you're in the engine room or rounds, and you tend to activate the dead man switch. The dead man switch is just a means of keeping you off, informing everybody that you're still okay. One of my cadets asked me, why is there a dead man in the engine room recently? And I was laughing. I said, it's not because it's a dead man. It's just that before you get to that point of dying, we should know what's going on with you. The dead man alarm is basically to keep everybody on board alert of your condition, the present situation you're in when you're in the engine room. I spoke to one of my AB a few days ago, and he told me the vessel is really an enclosed space. Your vessel is a container and is an enclosed space. The only reason we could move around and feel the vessel is okay is because we have air circulating in the system. That's why you have your HVAC system. Air is circulating, the doors are open, but when you're in an emergency situation, you shut down the old doors, your vessel is basically an enclosed space. And when you come to that aspect of it being an enclosed space, you need to be alert. That's why the control room is a means or is the brain of the vessel. It monitors everything that keeps that vessel running. That's what your control room does. It monitors your alarm, the alarm panel, the protection, your circuit breakers, everything, how they relate with each other, from your machineries, how they relate with the bridge. When the bridge presses a button, how do your machineries relate with that? How they respond to those commands. Your control room has all that information should be displayed in your control room. The control room is the intermediary between your engine and your bridge operation. Now let's look at the alarms that you have on board your vessel, the alarm, the sensor input. This is basically the means of your nervous system. Is the nervous system of the bridge, the nerves. Everything about sensors is basically telling you, oh, this is how it should operate, this is what should happen, this is how this vessel, this is the reaction. If the temperature is out, this is what you should do. If the pressure is out, this is what should happen. So it gives you the idea of how to manage those parameters. The sensor, you have the temperature sensors, the pressure transmitters, the level sensors, which tells you the level, whether it's high or low. You have the speed sensors and signals. All this is telling is, like I said, is a nervous system. It tells you how your machineries, how your equipment are reacting, and how you could manage them. If the pressure is high, it tells you, oh, maybe you need to do something to reduce the pressure. If the temperature is high, it tells you need to improve cooling or something. So your sensor system on board your vessel is very, very, very important. If you don't react on time to when those alerts comes in, when they are telling you this is what they are noticing, the next step would be you running at a critical moment to figure out how to stop an accident and emergency from happening. In most cases, people don't take all those stuff. You see an alarm comes on, you just press the button and you sit down. Your alarm system in your engine room is a sense of telling you something is going on somewhere. So whether it's a normal alarm, it comes on every time you're used to it, you need to monitor it when it comes on. I advise, please, you go down and you check why that alarm is coming on. If it's normal, fine, but you still need to check. I've had an instance where we always have a bilge alarm that was faulty, but that moment the bilge alarm came on, and my field engineer just did not move. He sat down there, and by the time we got to know, the whole engine room was flooded. We are talking about flooding, completely flooded. And we were at deep sea. We start having, we need to pump everything, submergible pump, put in place, everything we had to use just to get it done. But that was just basically, it's a normal alarm that comes in because the BIOS system was faulty. But in this aspect, there was really flooding. So a pipe had busted, but the guy thought it was normal. So whether it's normal or not, please, once you have an alarm coming on, that alarm tells you something is wrong and needs your attention. So it's best you go and monitor it. Let's talk about the safety system on board, your fire detection system, your CO2 flooding system. Your fire detection is basically telling you when there's an explosion or high temperature in place, you need to see what's going on. You need to be alert. We grew up with the saying that there's no smoke without fire. So once there's smoke, that tells you there's fire coming up somewhere. Once there's heat, it tells you something. Fire is about to take place. So we need to make all that happen in place. So uh, fire system needs to be monitored and looked out for. You need to put that into perspective. You need to monitor all of them. Emergency scenarios. Your CO2 flooding system, please. The CO2 is a very high risk system because in that aspect you need to evacuate because it's going to take away all total oxygen from the space. It shuts down your vent, it shuts down your blower, and it introduces CO2 into the system. And when that happens, anybody that is there is in trouble because when your brain lacks oxygen for a certain period of time, you're brain dead. Even if you're alive, you won't be yourself anymore. So it's a serious system that when it comes on, you'll see that it has to be announced. You have to take everybody moves to the monster station and you take account of who is on board, who is present. You need to figure out the people that are not there and get them all out before you introduce the CO2 system, the CO2 flooding system. It's sort of the last go-to call for fire on board the ship. The emergency stop is basically a means of shutting down a faulty machinery. If the normal stop is not operating, you just punch it and it shuts down the whole system. Another safety system is your quick closing valve, although it's not being put here. Your quick closing valve is a way of shutting down the operation of all combustible fluid in the system. Once that is activated, any combustible fluid valve is being shut down. It gives you a way of keeping everything in check. Let's look at the emergency scenario. We talked about the blackout initially when I was talking about the safety, the power distribution system. When we are looking at blackout, total loss of power, that's what blackout is. Everything shuts down. Like I said before, the first thing is in the next 45 seconds, your emergency generator should come on. Before your emergency generator even comes on, your emergency lighting should have been working, operating properly. So your emergency generator comes on. It's the idea of your emergency generator is basically to keep the essential services on. It gives you your cooling system, it gives you your firefighting system, it gives you an emergency steering system just to steer out of danger if you were in danger. It gives you minimum lighting. The emergency generator should run for a period of have enough fuel to run you for 18 hours. And that period is just to get you to the point of you figuring out what was the cost of the blackout. You need to rectify that cost and get the main power generation system back online and then go off the emergency generator. It should always be put in auto start so it kicks in case of any issue. Once the main power source trips out, it has a low voltage switch. Once it does not feel any voltage on that switch, the emergency generator comes on and clocks into the emergency switchboard. That gives you power for a minimum of 18 hours. That is enough time for you to figure out why your main power source went out. Engine failure, that might come on without having to lose without blackout system happening. You have a lot of issues on generators or main engines that can come up for different reasons. So those needs to be looked into. In most cases, like a quick fix is always, oh, you off it, you switch it back on and it works. Fine, if that's your own. But you need to monitor engine failures because in most cases, it's always at the most critical moment because the engine has to be running for you to notice there's a failure. And it's always when you're in operation. So that's a necessary thing you need to look into. Fire response and detection, you're looking at everybody should be versatile with firefighting system. Everybody knows our firefighting procedure. You need to do drills. You need to be ready in case of any outbreak. So you need to be quite efficient and alert in any issue that comes up. You need to be alert and prepared for it. The flooding control system, water ingress, bilge, those are things that in most cases people don't really look into the bilge system, but there's one aspect of system that tends to like drown the vessel because we are operating in water and that's the maximum capacity we have. When it comes in, it have access into your vessel. If you don't control it, it takes over. You cannot fight it. Once it has full access, there's nothing else you can do. So we need to know the best position to fight water, the best position to eliminate ingress, the best position which pump to run to take away the bilge or to evacuate water from our vessel. Now let's look at the watch keeping procedure. Like I said, if you're doing watch keeping, if you're looking at taking over watch, what are the procedures? What do you do? That's the first thing all of us needs to know. When you resume your duty, what do you do? When you resume your duties, what are your first steps before you take over watch? You need to know what your duties are, what the previous person on duty did, and how you're taking over that watch, where to continue. You need to check all your parameters. You need to know the position, the status of the machineries, the operating machineries, which one is shut down, which one is in operation, which one was being worked on, which one has been isolated. You need all those information when you resume watch. And all those information needs to be logged into the engine room logbook. You need to enter all of them for documentation purposes because that is the only way of knowing what really happened during your watch. It's not just during your watch, it's for emergency and it's for your safety. In case of any accident, that is the first point of call. In case of an accident, your logbook entries is the first point of call. It's like the black book for a flight. In the engine room, the logbook entry is paramount because when something happens, if there's any accident, if there's any emergency, that is the first place that they are going to. They want to see what you were doing, what happened during your watch, what were the parameters of the machineries, if there's a blackout, if there's an outbreak, if there's a breakdown. Did you notice that before it happened? Was there a warning before all those situations occurs? You need to put that into perspective. And the only way you could put that, you could follow that is when you have entered them into your logbook so you know the steps involved. Troubleshooting case study. Let's look at that. The aspect of marine engineering is basically troubleshooting because our job is not really to
Please,
build a
can you
ship.
share
Our
your
job
screen
is not
because my laptop went off? Is it possible to share your screen?
by screen.
Is it possible to share?
Okay. Let me see because I'm just taking the stuff from the one you sent to me. That's where I'm
Okay,
getting
is there
from.
anyone
Let
that
me
can
see.
share? I can send that the slide to the person. Is anyone that can share? Andonya, are you there? Can you share? Emmanuel, there, can you share? If you can do that, I can share the slide with you. Yeah, make
Let
you
me see.
co-host.
Um,
Yeah,
let me see.
I'm here, but
Okay, let me share
I'm using
screen. Let me
mobile
see if
phone.
that's possible. Let me see. That's. Let me see if it will work. Okay. I'm not sure I can share my screen. I'm not sure. Okay, I can't share my screen because I'm using my phone. I'm using phone because I'm on board right now. I
All right,
can't
sir. No
share my
problem.
screen. All right. But we're almost at the end because I think this is the last this thing, troubleshooting. Why I'm saying this is the job of a marine engineering is basically service and maintenance. Is not to build the vessel from scratch, is not to build the machinery from scratch. Your job is to maintain it and to keep it running from destination, your location to the next. It's not for you to do all every other thing. So the idea is you need to know the basic operating procedures of all your machineries. You need to be versatile in everything. That's the beauty of marine engineering. You need to be versatile in electrical, mechanical, hydraulic, pneumatic, plumbing. You need to be versatile in all that. Whereby a little bit of something, just a fuse blowing off, could cause a lot of issues for you. So you need to know how to troubleshoot a system. Troubleshooting is not like, it's basically having to do with if something happens, what's the step forward? How do you go about figuring out what is happening, what happened? It's not because, oh, you have an overheat, you decide, oh, it's basically you don't have cooling. There's cooling, your pumps are running, your system is okay, but why is it overheating? Is it your thermostat? Is it a block heat exchanger? All that needs to come in and you need to think fast. You need to think fast because some of those issues comes immediately and then it shuts down the whole system. That's why we monitor the parameters, we record them down because in most aspects, before you have a defect, before you have an issue, the system had already been warning you. It's just that you were not paying attention. If you pay attention, you realize, oh, if this value was 80 all these days, but few days ago it becomes 98, it becomes 100, you know something is wrong. That is the system telling you something is wrong. It's the recent issue I had on board, we had an issue of uh, a low boy cooler leakage. We realized our low boy was going down, but we didn't know why. We just thought, oh, the engine is burning low boy. And I requested, oh, let's top up the low boil and we put in more low boil. The next thing we realized the radiator was coming, low boil was coming out of the radiator. But something should have warned us from point one that the level of the low boil going down was quite high. We noticed that it went down quite fast. Well, we just thought, oh, something else was going on, but that is it. The system had already warned us, but we just weren't paying that much attention until we realized it was coming out of the radiator cover. So we knew something was wrong. That is the idea of troubleshooting. And when that happens, some people panic, you start seeing people running around, but you have to put two and two together. You figure out, oh, why is this happening? Where is this coming from? What is the closest reason for the main source of this happening? That is something we need to be versatile in. Like I said, you need to know your electrical system. In electrical, it's one of the funniest aspects of it. A short circuit, a simple short circuit or a blown fuse could be the reason for everything falling apart. I'd been on board a vessel where a single fuse had caused the generators not to synchronize. For 3 months, we called the manufacturers, it was a big issue. For 3 months, a single fuse. And when it was found, we all look stupid just for that. Poor contamination has been an issue. Low pressure has been an issue. You realize blocked filters. You just see simple things face this. So troubleshooting should be a core aspect of marine engineering. Like I said, our job is to keep the machinery running from one point to the other as we go about our duties. It's not to build a new engine, it's not to make, oh, you don't need to be a specialist because we have people that specialize in operating them, but you need to be informed of all the machineries on board. You need to be versatile. You are an all rounder, so you need to know a little bit of everything on board your vessel. So I think that's all for today. Thank you. If you have any question, please, I'm available. I'm on. If you have any question, please. I think that's all for today. Thank you very much.
All right. Thank you so much, Engineer Ante, for the insightful lecture. My apology to everyone. The gadget I used just went off, so the screen lost. I tried sharing to others to see if they can share it. So we end up getting it at the end of the class, but it's all fine. I want to believe that everybody jot down one or two because you cannot go to the farm without code. How will you read? Even if we have to have a slide uh, display, you still need to jot things down because the presenter might not put everything into the slide, but as he's presenting, something might come up and he has to mention it. So the reason why you have to come to the class with your pen and Bible so that you can jot down things. So my own, I would just want to contribute some in just one topic so that will not keep us waiting because I understand that our presenter is on board and this was supposed to be his rest hour, but decided to sacrifice it for us. So we say thank you. My one is on the turbocharger. I just want to add one or two on the turbocharger. Yes, a turbocharger is a mechanical system that is being driven by exhaust gas. It has two sides, the turbine side and the compressor side. The turbine side is being connected to your exhaust manifold. So whatsoever the engine exhausts, it uses that to drive the turbine side of the turbocharger, and that will in turn run the compression side of the turbocharger. And it will then suck air, the environment air. Although we always know that the engine room is always warm or hot, so you cannot take that air straight to your combustion chamber. So it has to pass through after cooler. That's where it's going to be cooled down and further increase the density of that air before going to your combustion chamber. And of course, the turbocharger is being lubricated by oil from your engine. So if you observe that you're losing loop oil in your engine, sometimes might not really be that your uh, rings are bad. It will be that your turbocharger is bad because the turbocharger is fitted with mechanical seal. We have mechanical seal on the turbine side. You also have mechanical seal on the compressor side. So the mechanical seal of the compressor side, if it is bad, all the oil will be dumped at your aftercooler. But if that top for turbine side is bad, it will be going out through your exhaust. And then you see that your exhaust side will overheat and it will reddish. So that's just one or two I wanted to add on the turbocharger. Also, this is part of for also exam question. They normally ask either in oral or in written. You know, why do you have to pass the air through aftercooler? It just needs to cool it down and further increase the density of that air before going into your combustion chamber. Then another one is just on the dilution because it could be fuel dilution, it could be water dilution. And for you to be able to know this, if it is full, your lipstick would increase, right? And if you taste the oil with your hand, if viscosity will not be there, it will be either lighter, that is full. But if it is water, the sum will change from the oil color to milky color. So that's one or two that I have to add. I don't have to take us much time. After this class, also, sorry that we lost the slide. We'll also share the slide to us. If you are not in their WhatsApp platform, please drop your phone number so that we can add you there. But if you are there already, no need to drop it. We'll share the slide at the WhatsApp platform. So I leave the floor for any question or any further contribution before we call it a day. Thank you.
Good evening, sir. Can you hear me? Can you hear me, sir?
Yeah, good evening. Yeah, you. Loud and clear.
I have a question. So, thank you so much, Engineer Mkpa, and say that was a very nice presentation. I really learned something from it. I really appreciate it. Thank you so much. Okay, my question is number one, the high compressed air in terms of starting engine with high compressed air. And you spoke something, you said that something about some ships are neutral ships with no electricity. So my question is, what if in ships like that with no electricity, then you want to start an auxiliary engine, a big engine with compressed air? What if you have had an air leak somewhere in the tank? How will you go ahead to still start the engine? What do you do there? What if the air is not available enough to start the engine? So that's the first question. And the second question is, why does the emergency generator run for a short time? Like, how short is the timing? Is it like for a day? Because there are some troubleshooting when a fault occurs. There's some troubleshooting that takes more than a day to troubleshoot and find the fault before we can start fixing it. Now, how short will the emergency generator run? What if you're unable to figure out the blackout in time? Thank you so much, sir.
Okay, about considering the starting of the engine, it's mandatory from RSTCW requirement that all engines must have minimum two means of starting. It's mandatory. That's one of the requirements. Minimum two means. So you could have the air starting and you would have your electric motor, your battery starting system. So if you have air leakage, you need to have another means of starting that generator. That is a requirement, minimum two independent means of starting your generator. So if you lose air starting, you need to have another means of starting it. So that's one of our requirements. Like I said, the air starting aspect, most why we see the air starting aspect is basically because if you're using a battery starting, each time you start, the battery is being run down. Each time you start, you're utilizing the battery, then the voltage keeps going down. So if that happens, then you're looking at, oh, having always to change the battery, and that's expensive. But in the aspect of air, you just pump the air in there and you save it in a bottle. It doesn't cost you anything apart from the compressor kicking in and compressing the air and saving it for you. You understand? So that's just the idea. But it's a minimum require you must have two independent means of starting your engine, your generator on board. So that's another way of putting it. Then considering the emergency generator is also part of the STCW, is a requirement. Your solars also puts that into where it has to run a minimum of 18 hours. The tank, like I said, the fuel tank for your emergency generator is independent of your main day tank, completely separated from the other source. The idea is to have enough fuel that will run for 18 hours. Because you don't know the reason why you have a blackout, whether it's dirty fuel or any other source, they need you to have a means, a way of keeping your emergency generator on for 18 hours while you figure it out. That does not mean if you realize, oh, your fuel is clean, the issue is not from the fuel, the quality of fuel you have, you can still transfer fuel to the emergency generator tank. But the condition is for 18 hours, you need to figure out what happened, why your main source of power supply is not has been blacked out. So that's just it. 18 hours minimum. The tank for the emergency generator must take you for a minimum of 18 hours. If by that time you think you figure out, oh, the fuel is not the issue, you can transfer fuel and keep using your emergency generator. But what about if the fuel the quality of the fuel was the case. So in that aspect, it should not affect the fuel in the emergency generator tank. So that fuel should last you for 18 hours while you figure out how to get another clean source of fuel to run the system. So that's just why that condition is there. It doesn't mean you can't run it further. It just means that is the law, the rule for your ship. That as long as that is done, till you figure out why it's that way, the emergency generator should last you for 18 hours, please. Right.
All right. Thank you so much, sir.
Hello, sir. Good evening, sir.
Yes. Good evening.
I want to ask, you spoke about the boiler system. I want to really
Yeah.
ask what the boiler system is for. Is it used to start the engine, or is the basic use of the boiler system the utilized steam? What is it used for?
Okay, it depends on what type of vessel you're on. If you're using a steam turbine, the boiler system is massive. You're talking about high temperature, high steam pressure. You're looking at very high steam. So in that aspect, the boiler generates steam of about 50 bar or so. So that steam is being used to run your steam turbine. It comes in as a high pressure air to rotate your turbine for it to run your steam turbine. But the most, when you're talking of auxiliary boiler is just a backup system. It's not like the main boiler. In that aspect, you could use it to heat up your fuel tank. If you're using HFO, your heavy fuel system, you use it to warm the fuel before you use it. If you're running in a cool region, a western region where the temperature of your fuel is low, you use that to warm it up before you could use it. In some aspect, it is used as your heat system for use on board the vessel, hot water. You understand? So when it comes to, that's why the name is auxiliary. It's not the main boiler. When you talk of main boiler, that's when you're using it as a means of driving the system, of driving the vessel. So that means you're using a steam turbine to drive the system. But when you talk of auxiliary, it's basically a backup system. That's why they call it an auxiliary. So it's not like using it to drive the system, you're just using it as a backup for to generate heat for other use on board the vessel. So that's just it.
Okay, sir. You spoke about cooling system, and I want to ask.
Yes.
I didn't really get you. You said separating two fluids. What's it called? Separating two fluids, and there's one statement. There's one word you use. I didn't really get that word properly when you
All right.
spoke about.
I said the heat exchanger separates two fluid of different temperature. It keeps them apart, but the only thing it does is they only interact by heat transfer. Their interaction is in the aspect of heat transfer. When one takes the heat from the other. Are you getting me? It
Okay,
takes
so
like the one with the high temperature loses that heat to the one with the low temperature, sort of trying to balance each other out.
so when we are talking about what's it called? Seawater cooling, and
Yes.
seawater cooling to cool your loop oil. It means the heat is transferring
Mhm.
from the seawater,
The lube
from the
oil,
loop oil
no,
to seawater.
to the seawater, yes.
Okay.
Because lube, your seawater is basically normally cool, you understand? But your lube oil
Okay.
running through the system is very hot, so you need a way of reducing that temperature before it goes back in again. If you're not cooling that lube oil, when it comes out, you're looking at about 80, 85, 90 degrees of the lube oil temperature. Then putting that back in the system, the temperature keeps increasing. So you need a way of controlling that temperature. So that's where you use your seawater to take out the heat from the lube oil. So when it gets back in at about 70 degrees or 65 degrees, and then comes out again at 90, 95 degrees for you to continue, take it off again. So that's the idea.
Thank you.
Well, just to add to, because you asked a question, what steams is being used for on board. Just as you rightly said, that it depends on the type of the vessel. There are some vessels that carry cargoes, not just heating your heavy fuel oil.
Yes.
There are some cargoes that you carry on deck that will require heatings. So the steam, there are pipe that runs through those cargo tanks. So steam passes through it to heat those cargo. Then another one also just depend on the type of vessel. You also use that steam to run your anchor wings, your windlass. So you use the steam to run to lower your anchor inside water and also to heat your anchor back to our pipe. So those are another two things that their steams are being used for on board, depending on the type of the vessel.
Sorry,
In all that
the
aspect,
windlass, the windlass. You said the steam is used for what when it comes to the windlass system?
There are some windlass that use hydraulic. I said depending on the vessel. There are some windlass that you use steam to run it.
That's to boom up
To run
the
it to
anchor.
lower down your anchor inside the water and also bring back your anchor. So you use steam to
Okay,
run that. You also
okay,
use steam
thank
to
you,
heat the cargo, depending on the type of vessel, depending on what the vessel is carrying. You use steam to heat the cargo.
thank you.
Somebody asked a question in the chat box. He's saying that what was the question? Talking about turbocharger. I want to ask if this turbocharger that is overheating, is your engine also overheating? And also, are you losing loop oil from your sump? Because if the mechanical seal on the turbine side of the turbocharger is bad, when loop oil is passing through that turbine side, that exhaust will be very reddish. So these are the things you need to check also. The issue could be that your turbocharger also is defective. I don't know if anybody in the house also has something to add to that or subtract. Let me just read out the question. He said, "Thank you, boss, for the lecture, sir. I have a problem with my engine rising in temperature of exhaust after turbocharger when the engine is at about 1,400 RPM, above 600 degrees Celsius or 600 degrees, which abnormal. What could be possible that cause it? And also, don't forget there are some turbocharger. I don't know what CC32 is using. There are some turbocharger that also have a means of cooling it with water. It has a jacket, a water jacket, so water passes through it to also cool it. Even the oil that is lubricating that turbocharger also not only to lubricate, it also serve as a cooling agent. So the mechanical seal, if it is bad and oil is leaking into the turbine side, will also make the turbocharger to overheat. Any other person? We have other engineers there. If you have one or two to add, I think it will also help. Thank you.
Okay, I would like to add that it can also be an airside problem. I've had an experience where the turbocharger was getting overheated because the air filter, the felt filter that was used to cover the turbocharger was blocked. So it was not getting air, and that starvation of air coming in through the turbocharger, it can cause overheat because the air fuel ratio in the cylinder is distorted, and then the exhaust gases that are coming out, sometimes you get after burning, and then the turbocharger is not getting enough cooling efficiency from the air that is coming in also, and it's not able to run as fast as it's supposed to run to meet up the the speed requirement, because when you go to 1,400, when you're running at high RPM, you need to have enough air coming in and leaving and proper exhaust. So you have to check your air side. There could be problems in your air side. There could also be bad spray of fuel. So you check also individual exhaust temperature of each cylinder to see if there is any cylinder that is getting a very high exhaust temperature. If you find that, that means that you have a problem with your injector. It can also be a problem with the valves. You can also know that if there's a particular cylinder that is having some issue. If there's exhaust valve that is burning, the combustion gases from that particular cylinder will be flowing out through the turbocharger, and that can also cause overheating. So you check all of that, and then you need to also go to the turbocharger and check accurately with maybe a temperature gun that the turbocharger is actually overheating. That is not just so it can be a sensor problem. Sometimes you see the temperature, but it's not actual. So you need to do that check also. That's just my contribution. Thank you.
Thank you very much. All right, guys. I really appreciate you guys having me tonight. I think I'll be leaving soon. Like I said, I'm on duty right now, so I'll be logging out very soon. I appreciate this opportunity given to me, and I appreciate Engineer Mkpa for doing this. Thank you, guys. It's great being among you guys. Have a great night, though. Bye.
All right. Thank you, sir, for your time. Thank you for sacrificing your rest hours for us to give us this insightful lecture. Engineer, well, please over to you. Just give one or two announcements. Then we call it a day.
Thank you very much, and thank you all for attending today. We really appreciate that over the short notice you are able to log in and join us today. And as we have promised, there will be more seminars coming up, there'll be more lectures, and we will also be organizing um, not just one day, but some trainings that will span over a couple series of weeks so that we can actually get into some questions and answers and practical theories that is required. If you have any question that you need to know, for those of us who have not been on board, if there's something that is strange to you, for those of us who are just new on board, maybe you are doing your kedeship or you are an oiler, and there are things that you cannot ask the engineers on board, you can always drop it on the group and we will assist you in any way possible. If you also have troubleshooting issues, you can drop them on the group and we will troubleshoot together. We can share pictures with you and let you know what to do next and give you all the necessary support. So we just want you to know that we are always there for you as a support as it concerns marine engineering and whatever issues that you may face in the industry. Thank you once again for joining and see you in the next class.
All right. Thank you, guys. If you don't mind, you can open your screen. Let's take a screenshot. Wait, please also help us to take a screenshot. Guys, let's go. If you don't mind, you can open up your screen. Let's take a screenshot. Thank you. Then we wrap it up.
Okay, guys, let's turn on our screen as we take a screenshot. All right. So many people today. Okay, thank you very much. See you again.
On the street, on the street, on the street.
Which group? So when you're on them call a video call. Video call.